Hello, and welcome to your Week 2 lecture video for OSL640. Hopefully you didn't miss last week, and this is not your first week. We did a synchronous lecture last week. All your lectures from this point along will be asynchronous, meaning you're going to be watching a pre-recorded video, and we will meet together in the lab class, which is your second class in your schedule for the week. And work through the tutorial together, and I will answer questions, help you troubleshoot issues with commands, stuff like that during that time. So ideally, I recommend that you take notes about anything that you have questions about while you watch these videos, and I will answer them, bring them to the lab class, and I will answer them in the lab class. So you're going to get, I've divided these lecture videos into two parts. So you're going to get Lesson 1 and Lesson 2 as separate videos. Watch them before the lecture, both of them, but it separates them out a little bit, so it makes it just a little less time-consuming content-wise, and that way if you have to review something from the first or the second half, it's not a big deal. So, with all that in mind, this week we are looking at Unix and Linux file management concepts and how to manage directories. Last week you learned a lot of stuff, really, what Unix and Linux is, where it came from, and so on and so forth. And I did mention that one of the important concepts to the way Unix and Linux work is that everything is a file. So file management is an important thing. So in this first lesson, we're going to look through the purpose of directories, path names and tree diagrams, and file naming rules. There are particular rules when it comes to naming files in Linux. We're going to look at some commands to create, view the contents of a directory, manipulate files and directories, and remove directories. So all these commands here, mkdir with the -p option, and without, and when you need it, rmdir, rm, with some options there as well, ls with some options there as well, the tree command, the copy command, which is cp, and there's an option for that that's common that you may or may not need, and the move command. And this will all tie into Tutorial 2, Investigation 1, and the first 8 practice questions at the bottom of Tutorial 2. Ideally, you should use some of the concepts learned from this to better organize your files within Matrix, because you may have files from multiple accounts, multiple courses, I meant to say, and it just, a good sysadmin likes a nice, neat, organized directory tree with everything in its right spot, so you can find things instead of just dumping everything into one file, or even worse, dumping things onto the desktop. Kind of drives me nuts. So you may want to organize your files into directories and possibly even subdirectories, and it's useful to learn how to use Linux commands for navigating and manipulating directories and files, because this is an essential skill for both Linux users and sysadmins. Some of you may end up being future Linux sysadmins, or you may end up being a future Windows sysadmin, but either way, having a nicely laid out file system is an excellent skill. So when we look at the Linux file system, it's hierarchical, just like other operating systems. The main difference is you're used to, drive C or D or whatever drive letters in Windows. We don't have that in Linux at all. In Linux, everything descends from root, which is represented by a single slash. And if you're looking at your keyboard, that's the slash right beside your left shift button, which is also the question mark key. So root is the the parent directory to every single directory within the Linux file system. We have child directories, grandchild directories, etc., all the way down. And this directory structure resembles an upside-down tree. And there's actually a command called tree that will display your directory diagram in a tree format, which is kind of useful. We're going to look at that. It's a particularly useful command when you're first learning Linux and you're moving things around and you want to confirm and make sure things are where you are. I'm a fairly visual person, as are most people. So having two terminals open side by side and a tree in one and moving your files and commands around in the other when you're first learning is useful. I found that useful when I was first using Linux. Path names are used to specify the location of a file within the file system. And this path name points to a file system location by following the directory tree hierarchy expressed in a string of characters with various path components. Each one is separated by a single slash. So for example, home, your Seneca ID, well, we now know that this represents root. So home is a subdirectory of the root folder, and your ID is a subdirectory of the home directory, which exists in root. There are several common files that are interesting. Interesting in terms of their use, but they're set aside for specific uses. Some of these are really interesting. So for example, slash is your root directory. That's the ancestor to every single directory within the Linux file system. Home is used to store every user's home directory. Every single user on a Linux system has a home directory. So therefore, home slash and a username, those are specific usernames username home directories. So for example, my home directory is /home/jason.carmen. Bin and user bin contains system binaries, which are commands. Bin is easy to remember because bin is short for binary. User, that's what USR is short for, incidentally, that's user. User sbin contains system binary utilities that are commonly used for system administration. So anytime we're invoking a command, it exists in the file system in one of these directories, for the most part. etc. The etc directory has a funny history. It's come to be one of the most important directories in the file system. It contains all kinds of system administration files and pretty much every configuration file for every service. And you're going to learn more about configuring services and configuration files for services next semester. Not really much this semester. But all of those configuration files tend to reside within etc, so it's a very important directory. But when they were first laying out the Unix file system, they weren't sure where to put these files. So they literally created an etc directory and just tossed them in there. Anything they didn't know what to do with went in etc, and that happened to be all of the important stuff. I always found that pretty funny. Var contains, so it's short for variable, contains dynamic files. Generally speaking, they're log files, mail files, files that change in size, or will change in size. Sorry, I had a text message pop up. Temp, TMP, and var temp. It's used for temp files from programs. So anytime a program or even a script creates a temp file for something, you should create these if you're writing a script or a program. Have them created in temp. And finally, /dev contains all your device driver files. So things for terminals, printers, anything that requires a driver, which is really any piece of hardware in your connected to your PC, has a driver file in dev. When it comes to creating directories and files, well, here's some specifically directories. Here's some important rules to determine or to keep in mind when determining appropriate file names. First and foremost, and I touched on this briefly last week, all characters in Unix and Linux are case sensitive. Therefore, all file names and subdirectories are case sensitive. So, bin with an uppercase B and a lowercase b are not considered the same. You should adopt a somewhat consistent directory naming scheme, and this will help you better be able to better navigate within your directories. And make sure you make directory names meaningful, short but descriptive. So instead of creating a directory called something vague like stuff or things, create it with what's going to be stored in there in mind. So for example, if you're creating a directory for notes and materials relating to this course, calling your directory OSL640 might make sense. Introduction to Linux might be a little long, but the course code makes sense. And this holds true for, it's a good example. It holds true for everything. You should avoid using spaces ideally in directory names in Linux. I know most of you come from a Windows background as Windows users. And Windows doesn't care about this. It also doesn't care about upper and lowercase names. You can pretty much do whatever you want with Windows files. But with when you're using spaces for directory names and file names, it can cause issues. You have to then quote the space, and we're going to look at quoting special characters in a couple weeks from now. But you should just omit it entirely. I know when it comes to web development, when you're accessing and referencing files on a web server, if there's spaces in a directory, it causes major issues for linking to that. So instead of a space, think about using periods, hyphens, or underscores instead, or shorter file names and directory names that don't require any of those. And you should avoid non-alphanumeric characters. So stick to letters and numbers, because anything that's not an alphanumeric character has a special meaning in the system, or to the system. They're referred to as special characters, and we're going to learn about those in a few weeks. Common commands to create and manage directories. mkdir, which stands for make directory, allows you to create a directory. You can include the optional -p option, which stands for parent, and that will create parent directories and then the directory specified in the path name. If you're creating some subdirectories, you can do this all in one line. We're going to look at an example of that shortly. You can use rmdir to remove empty directories. A note about rmdir is it only removes empty directories. So if your directory has files in it, either delete them first or consider using rm instead. Rm deletes files. It's used for, or means removes files. You can use the -r option with rm, and it will delete an empty directory with contents and all of its contents. But be careful with this one. For novice users, it's highly recommended to use the -i option, and it will prompt you for each file if you want to delete it or not. Just until you get more comfortable with this. And always be careful in the context that you use this. Finally, ls. Well, we looked at ls, right? It lists directories and contents, but we can include a couple other options with ls that might be useful that we haven't looked at. Last week we looked at ls and we looked at ls-l. If we include the -d option, it will list a directory but not its contents. And if we include the -R, it's for recurse, so it will display the directory and any subdirectory contents, which could be useful. Tree, we mentioned a few slides back. Tree will display the diagram of the directory structure as a tree. And you're going to see all these in action, so don't worry too much. CP will copy files. Note, if you're copying a directory, you need to include the -R option for recursive, and that will copy a directory and all of its contents to the directory you specify with the command. And then finally, move, MV, moves directories or files to a different place in the file system. And an interesting note about move, the move command, it's also used to rename files. There is no command for specifically renaming files. We just use the move command. So let's have a peek, and we're going to create, I should have edited this first. We're not going to create this directory structure right here. Let me see if I can overlay this decently. We're going to create this directory structure. There we go. Look at that. I'm going to edit these appropriately after I finish recording this. I thought I'd edited the screenshot. I did it in the tutorial, not in the slides. So we're going to edit this, or we're going to create this directory structure here and do some things with it, manipulate files and move things around, so on and so forth. And we're actually going to do this in tutorial 2 as well. So I'm kind of giving you a preview of some of the things you're going to do in the tutorial. All of the steps might be a little bit different, but should be more or less the same. So you're going to be doing this in your home directory. I'm not doing that in my home directory, just because I've got a ton of files in here, and I don't want to have to go through all of these other things that I've got from either ULI 101 or when I created some stuff for this course when I did the and ran through the tutorials. Incidentally, I did test all the tutorials. So all the instructions that were written for the tutorials, I've tested them and ran the check scripts against them so that I know they work. So yeah, I'm not going to do things in my home directory. I've created this demo directory specifically for demonstrating things to you guys. But use what directory it tells you to use, or wherever it tells you to put things in the tutorials, because otherwise the check scripts may not work quite correctly. So I'm just going to clear my screen. Those were kind of some commands we used last week as well. First I'm going to create a couple different directories. Now I could do each of these individually. And actually, let me try doing it individually first. I'm going to create that directory tree. So we have mkdir OSL640 XX, mkdir OSM620 XX, mkdir NWK 680 XX, and then finally mkdir OSL, or I shouldn't say finally, I'm not quite there yet, OSL640 XX notes. And note, once you've got the directory and you're creating subdirectories, you can hit Tab to autocomplete. So I'm going to make the tutorials, and finally the samples directories. And then I can do an ls and see that my 3 main directories are there, and I can issue the tree command to confirm here's what we look like. Now that was a fair bit of work, wasn't it? We had to create each one of these individually. We could have done this all on one line with the -p option. So I'm just going to get rid of everything with the rm command. I'm going to use a wildcard here. rm star will expand to everything. or sorry, anything. So I had to use the recurse option with RM there. I'm going to do an ls to confirm that everything's gone. And then I'm going to clear my screen. So now that I've done that the long way, I'm going to show you how to do that the short way. Much shorter, using the -p option. So mkdir -p. We're going to do this because we want to create the OSL640 plus some subdirectories in it. And that is OSL640, sorry, XX. That's the parent directory. So OSL640 XX. I'm going to show you something kind of cool too with this. Notes, tutorials, samples, OSM620, and NWK680. And if I do an ls and a tree to confirm, look at that. Wasn't that so much faster than what we did before? Now note here, with the inclusion of the -p option, I created OSM620 and NWK680 separately, but I didn't actually issue a command to create OSL640XX on its own. When included with the 3 subdirectories that I had created within it, it created this directory. I didn't have to tell Unix or tell Linux to create that directory separately. That's kind of neat. It saved a fair bit of typing, and it's everything all on one line. This is an example of how you can speed up your productivity and your workflow by working just a little bit more efficiently. So I'm going to copy some files around just to show you how these work. And I'm going to use the tab autocomplete option a fair bit in here. That's what I just did there. Just because it speeds things up a bit again. Work smarter, not harder. So there we go. We see we copied. If I look at the OSL640 subdirectory as well, samples is in both. So we copied it. Now we're going to use the move command. We're going to move notes. And take a look. whoops. So if I do an OS on OSL640 as well, or an OS and LS, too many O's and L's. So that worked. We moved the notes directory. It no longer exists in OSL640, and we moved it to the samples directory. Now let's get rid of all these and clean up our file system. So note, we want to remove. I'm just going to do a tree quick, actually, just to show you what we have here. So we want to remove OSL640 XX, OSM620 XX, and its subdirectories. So we have to remove recursively files. That's what the F stands for. And if I do a tree to confirm, they're gone. And an ls as well. And then finally, we're going to get rid of that NWK680 command. Now, because it's an empty directory, we can just use the rmdir command. And do an ls, and there's nothing there. Everything is gone. So last week we looked at the ls command and the with the -l option as well, which remember gives you a long listing. And I mentioned that I mentioned all these fields do other things that we're going to look at later in the semester. Now is the time for one of those. That first character there in this string before the file tells you what the file is. So there's three options there. If it's a D, it means it's a directory. If it's a dash, it means it's just a regular file. And if it's a B or a C, it means it's a device file. So that's interesting. Another note about files. You can make a file a hidden file within the file system by including the period in front of it in the file name. So this will hide a file, will also hide a directory, and they won't be shown when you issue the ls command. Now, why might you do this? Well, you might do it to clean up the directory a little bit, or to hide something so it doesn't get accidentally deleted, like a backup or some other important file, just to make it a little more hidden in the file system. It doesn't encrypt it or anything, it just hides it. Although you can, if you have the appropriate permissions, see it with the -A. So anytime you've created a directory or file with a period in front, when you issue ls, you don't see the hidden file or directory. You won't see it. But if you include the -A option, lowercase, it will show all files, including hidden and non-hidden directories, including the current directory, which is represented in the Linux file system as a single dot, and the parent directory, which is represented as 2 dots. The uppercase A option will do all of the same thing as lowercase a, except current and parent directories, so your single dot and 2 dots, aren't displayed in the output. To get some practice with these things, you should do Investigation 1, Managing Directories, in Tutorial 2, and practice questions 1 to 8 will directly map to those. So you can get into these by simply control-clicking on the links within the slides here. They're on the weekly schedule in the tutorial. There's lots of methods to work on, or to access those, and we are going to be working on Tutorial 2 this week in the lab. And that brings us to the end of our first half of this lesson. So feel free to continue on to watch the Lesson 2 video, which I'm going to continue recording separately momentarily. So if you're going to watch them back to back, I will see you in just a few minutes.